I hope all of you are well, okay, and this in the midst of this pandemic, and this is the new normal. I mean, um, we'll meet more in the virtual platform rather than face to face. At the very outset, I would like to make it clear to the participants that this lecture series is primarily meant for the students. It's not that the non-students can't join, but well, the main rationale of this lecture series is to introduce the students of social sciences on how the scientific method has risen in the West, mainly in the West, and maybe in the next series we will I will try to introduce the scientific method, actual scientific method in social sciences. Well, this will be a 3-part or maybe 4-part lecture series where I will try to introduce different concepts among the students in a rather lucid way, and there won't be any high-end intellectualism in this seminars, in this lectures. So primarily, my first thing is that I am not from philosophy. I'm all, and the entire branch of philosophy or entire subject of philosophy won't be discussed here. Only that part will be discussed which are directly associated with the scientific method in social sciences. So my primary target is students, because throughout my teaching career I found that students are at loss on how they will see the scientific method, how the scientific method has come into being in social sciences, and I felt that if they don't have a proper idea on this issue, they won't be able to formulate good theories or maybe hypotheses in their life. And throughout my teaching career, I found this lack among the students. During my student days also, I had this kind of lack. I mean, later, after I passed out, I got introduced to several methods, several scientific methods, and the history of scientific method in social sciences. Now, let me share the screen with you. I hope all of you are, I'm audible to all of you. I deliberately kept kept the participants mute, because there would be a kind of I have 2 hosts here, and I'll tell them that admit the participants as and when they come, and I'm going straight to the lecture. So what are the main areas of social sciences? First thing is that these are the subjects that are considered as a social science child subject. anthropology, then sociology, political science, then we have psychology, economics, then there are borderline subjects like history, who are kind of in and out of social science, archaeology, geography, demography, law, and linguistics. These are sort of areas or the subjects that are considered within social sciences. Now, having said that, we have few basic questions we'll have to consider during this lecture series. One is first question is, are natural things permanently or fundamentally rather different from social things? I mean, when we talk about natural events, is it or are they fundamentally different from social events, social things? Second question that will be addressed during this lecture series is that must then be sciences of social things use different methods from the sciences of natural things? We must address this thing also. Third question that we will address here is are then sciences of the social at all possible? So if the natural things and social things are different, then sciences of social, sciences that deal with the social things at all possible? Alternatively, social things, are social things mere aggregates? So say for example, when we try to gauge the community behavior, will it be an aggregate of individual behaviors? Or maybe when we try to delineate or rather analyze a social pattern, shall we consider this social pattern as aggregate of individual behavioral patterns? Then another very important question that will be addressed during this lecture series is, do social things mix facts and values? I mean, whether we the human beings mix values with the facts and then analyze things? Can we have an unbiased assessment of facts that is separated from values? And then, are values a social product? I mean, is it really the fact that the society that we are in creates our values, whether we are brought up with values or whether the values generate independently of our bringing up? These are the six basic questions that we will address during this lecture series. Now, let us see it in a different way. I mean, it's very elementary, but I must tell you that social science as a subject has always engaged with traditional philosophical concern, ontological concern, epistemological concern, and normative concerns. We'll address these three things later. But we must make it abundantly clear that the subject, the social science as a subject, is inextricably bound, inseparably bound with traditional philosophical concern. Our social things are very much entrenched in traditional philosophical concerns. Now, this is the plan of this lecture. What I will address today. Today, I will address these topics: sources of knowledge, then scientific method, and scientific claims. These are the three things that I will address today without being gibberish or without being sort of I'll try to make it in a lucid way. I'll try to explain it in a lucid way to the students. Now, sources of knowledge. What are the sources of knowledge? How people base their knowledge on day-to-day life. One, there is intuition. Two, there is belief. Just think of one of your knowledge, and you will find that most of our knowledge in day-to-day life, not when analyzing the generalized things, day-to-day life are based on intuition and belief. We are living within a pandemic. Some of us have a kind of intuition or belief that they are very strong and the coronavirus won't really affect them. So they get out of their house without any mask. They just chat with each other. They do all kinds of wrong things that are being advised by the doctor and the epidemiologists. So intuition and beliefs are the two ways that we normally base our day-to-day life, normally do the things in our day-to-day life. But whether intuition and belief is a very good source of knowledge, that's a very big question. Say, for example, here you are. Let's say that the man there is my student Ranjan, and on his right, his dog Aduri. Now Ranjan is unmarried, hopefully bachelor, and Aduri, his dog, loves him very much. Whatever he does, Aduri repeats. So Ranjan has a kind of intuition and belief that Aduri loves him most in this world. Well, that's a good belief, day-to-day knowledge. Now the inevitable happens. Ranjan has got a very beautiful fiancée. And when his fiancée meets him, his dog spends most of the time with his fiancée. So Ranjan's intuition and Ranjan's belief that Aduri loves him most doesn't stand well. So belief and intuition is not a good basis of knowledge. Now, why it's not a good basis of knowledge? What if someone else holds an opposing belief or intuition? Yeah, Lord Ranjan's fiancé holding an opposing view or intuition, any belief, any knowledge can have so many opposing beliefs and intuition. So that's the first pitfall. Second pitfall is that, say for example, we have a consensus on certain knowledge. What should I say? I mean, there is a consensus that Krishna is an archaeological character. Krishna is a historical character. So a consensus doesn't make it a valid knowledge. Krishna is a mythical character. So if everybody believes that, well, Krishna is a historical character, it doesn't make Krishna a historical character. So consensus always doesn't make a valid knowledge. Then the most important example is the knowledge where everybody was in consensus that Earth is flat. For a very long time, this knowledge was there, and that's a consensus knowledge. But well, we found Earth as a round one. So the debate of Earth, flat Earth versus round Earth, makes it clear that belief, even a consensus belief, doesn't make a basis of good knowledge, good basis of knowledge, for knowledge. Now, another very important source of knowledge is that authority's opinion. Somebody is making scratches on my slide. How can a person do that? I don't know. So, authority's opinion, I'm not sure whether I can erase these scratches. Okay, if you like, you can go on creating this nuisance, but well, that's not a very good thing to do, I think. I don't have eraser here. So, authority's opinion. An authority's opinion. A political leader, experts, gurus, and scientists say something, and we tend to believe that. Well, this is sometimes forms a better source of knowledge, but well, it's also not always a better source of knowledge. Because, we always think that these authorities have an access to more or better knowledge. But they have important personal stakes. These authorities have important personal stake in getting their views accepted. Their careers and reputation may be at stake if they say something else than what people want or what the higher authorities want. So we have always seen that scientists are buckling down to the political leaders. Political leaders are buckling down, or rather bowing down to religious gurus. Everybody, scientists, experts, political leaders, all succumb to the gurus. So the gurus' sermons, not always a good source of knowledge. Now, I'm giving an example. Climate change is a kind of, everybody know that climate is changing, our globe is warming, global warming is a phenomenon. So, but what about this moron, this guy? He doesn't think that climate is changing. Global warming is a myth, according to this guy. So there you are. Authorities' opinion are not always good source of knowledge. Another very important source of knowledge that we think is the observation that took casual observation. Now we gather evidences through observation and casual observation. It's better foundation, but still not good enough, because we are not always good observer, and we are not good observers. We are selective in our observation. We selectively observe and remember things that agree with our beliefs. We don't want to observe anything that doesn't agree with our beliefs. Say, for example, Europeans for a very long time thought that swans are white because they have seen swans only in white color. So it's not unnatural, illegitimate, or rather unjustified to think that swan is white. Swans are white until they discovered Australia, where we find black swans. So casual observation, even long time observations are not always good source of knowledge. Now, another very important source of knowledge is logical reasoning. Well, it sometimes seems solid basis of knowledge. But the pitfall is, our informal logical reasoning isn't always consistent. Always not consistent. We talk about the majority community talk about the rights of minority communities. But when we talk about these, say for example, Hindus talking about Muslims, even progressive Hindus say that they are like that. Now, one thing is quite sure, that our logical reasoning is not always consistent. Sometimes we are very progressive, sometimes we are very conservative. There are endless lists of fallacies or logical inconsistencies in day-to-day reasoning. I mean, there are so much fallacies and logical inconsistencies in day-to-day reasoning. Now, one major logical reasoning is that, and we respect this logic, that more you read, more you learn. Is it true? How about this one? He reads, but does he learn anything? And it happens to every society. Sometimes even the most wise people are found to be very idiot. They are wise in one respect of knowledge, they are idiot in other respects of knowledge. Even in few domains, they don't look like wise. So the wisdom, the logical reasoning of wisdom is not consistent. So this is also not a very good source of knowledge, logical reasoning. So to make sure that our explanations of the world are valid, we must say that it cannot be based on subjective and unverifiable sources. It shouldn't be based on beliefs, opinions, and consensus. Beliefs, opinions, consensus, all can falter. We cannot really base on subjective and unverifiable sources to observe the world, to explain the world, which is valid. Casual observation and informal logic can be heavily distorted by our beliefs. So these are the pitfalls, and we must go beyond these sources of knowledge to make our observations scientific, our conclusions scientific. So we need scientific method, where we must have systematic observation, which is free from any bias, consistently applied logic. Logic must be consistent. It must not falter in some issues, some domains. It must stand in all aspects of that observation. Systematic observation coupled with consistently applied logic. So these are the two important sources of knowledge to get scientific method. Now let us go to the scientific method itself. So we need scientific method to know how the world works, result in valid knowledge. So whatever happening around us, it must be brought together in such a manner, such a scientific manner, which will result in valid knowledge. And not based on opinions, beliefs, casual observations, and informal logic. All these are too subjective, too susceptible to errors. Now, scientific method needs systematic observation and consistent logic, as I have said earlier. What is consistent logic? Chance of coming up with valid explanations. Say, for example, we have seen these things, seen something. The consistent logic tells us that we must come up with valid explanation of that phenomena. Evaluate the plausibility. Evaluate the plausibility of our scientific claims or hypothesis. I'll talk about hypothesis later. It's a scientific claim that something is to establish relationship between different things. So to make hypothesis plausible, we need consistent logic. And the strength of empirical evidence in favor of hypothesis it would be enhanced when we have consistent logic. So there are three areas that we must see consistent logic. Chance of coming up with valid explanations. We must have valid explanations of certain phenomena. The consistent logic must evaluate the plausibility, applicability of our scientific claims or hypothesis, and consistent logic must impart strength of the empirical evidence in favor of hypothesis. Now, we must There you are. Scientific method is described by 6 principles. 1, it must be empirically testable. Whatever we say or whatever we conclude must be empirically testable. It must be replicable. It must be objective. It must be transparent. It must be falsifiable, and it should be logically consistent. These are the 6 areas, 6 principles of scientific methods. We'll talk about each of these later, immediately after this slide. Now, a scientific study must meet these principles to be considered as scientific. If we falter in one of these principles, the method would not be considered as scientific. So a hypothesis then be compared to and compete with other scientific claims. So if I say, for example, we have advanced a hypothesis and we have proved through our observations that this hypothesis is good to stand. Now, it must be replicable and it must be falsifiable. There may be competing claims, competing scientific claims that can be projected against our hypothesis, and we must withstand the competing scientific claims. If we can't withstand, new hypotheses will arise. So all these principles must hold in a scientific method. All these principles must be there in a scientific study, must be there. And with all these 6 principles holding good, they provide best possible explanation of the world. Now let us take up one thing. First thing first, empirically testable. Science hypothesis is empirically testable. It should be possible to collect empirical and physical evidence or observations that will either support or contradict the hypothesis. When you are advancing a hypothesis, you must keep in mind that others are there who can collect empirical and physical evidence or observation that can support or contradict your hypothesis. Any hypothesis for that matter should be empirically testable. Say for example, we are in the midst of a pandemic. Many countries as well as pharma companies are trying to develop the treatment for COVID-19, and well, there are so many claims and so many counterclaims. When a final treatment will arrive, that must withstand the empirical or physical evidence that might contradict the hypothesis. There may be other empirical and physical evidences or observations that may support the hypothesis. So empirically testable. But what about a belief? Whether we can empirically test the hypothesis when it is based on belief or intuition. Say for example, if we ask Ranjan's dog, Aduri, who she loves most, Ranjan or his fiancé? Well, it's not a possibility. So it's not empirically testable. She himself says what? So it's not empirically testable. A hypothesis becomes scientific when it is empirically testable. Now, hypothesis must be replicable also. We should be able to consistently repeat the original study. It should be repeatedly confirmed. And if the expected results occur only once and few cases, result is coincidental. Once again, I'm giving you the example of from the treatment of COVID-19. If the treatment of COVID-19 or the vaccine of COVID-19, should I say, has been comes into the market, somebody else, the study must come up with all those details. Somebody else should be able to repeat the original study. And it should be repeatedly confirmed that this drug or this vaccine can cure or prevent COVID-19. First thing is that it must be repeatedly confirmed before it comes to the market. Second, even after it comes to the market, it may be repeatedly confirmed. It may have to be repeatedly confirmed. The entire treatment process must be replicable. The original story must be replicable. If the expected results occurs only once, or if the expected cure happens to one or few individuals, the result is coincidental. Now, let us go to this point, go to Ranjan's dog once again. Here you are. Ranjan is actually spending a very good time with his dog. Now his fiancée is not near him. Now he thinks that his dog loves him most. But, well, God forbid, if it happens. I'm sorry, Ranjan, but well, if it happens that if the dog dies, there is no way we can replicate the study. There is no way Ranjan's fiancé can prove that, or Ranjan, for that matter, Ranjan can prove who the dog was most fond of. Now, third principle is objectivity. Now, objectivity actually is that principle where ability to repeat the study themselves without the need for the original researcher. We don't need the original researcher, whosoever he or she may be. We have the theory, we have the hypothesis, we have the theory here. And we can repeat the study once again. Oh no, it happened again. So anybody should have same results on the description of the assumptions and procedures. So the original researcher must describe the assumptions and procedures behind his or her study. So when we have the assumptions and procedure, the results must be there, and we must have the same result or same conclusion. Otherwise, the study cannot be objective. The objectivity is that principle where we can repeat the study without the original researcher. Now, assumptions and concepts and procedures should be clearly and explicitly defined. There is no room for subjective interpretation in this principle. I mean, objectivity is must be there so that we can repeat the experiment or repeat the same thing once again, wherein we can repeat that, and with the assumptions, concepts, and procedures clearly and explicitly defined, we can go to the same conclusion. There is no room for subjective interpretation. So there is no room for subjective interpretation. How about this one? Well, he loves me not. Now, how would you conclude that whether, I'm not naming him, so say for example this guy, whether his fiance or his lover actually loves him or not. Can we have an experiment? Let us have two bowls. In one bowl, we have petals for he loves me, she loves me, and on the other bowl, we have the petals for she loves me not. And we can count, of course, as far as scientific method is concerned. And whichever is higher gets the final conclusion. I mean, say for example, if she loves me, the number of petals on the bowl for she loves me is greater, then of course she loves the guy. Now, can we get a kind of this conclusion with this exercise? No. I mean, these things are not scientifically observable. Even if we try to quantify this thing, a love or a depression or some other feelings are not scientifically observable. Fourth principle is transparency. Being transparent is a kind of primary requisite for a scientific method, and being transparent is actually synonymous to being objective. If you are not transparent in your result, in your writing, in your experiment, then you are not objective. So transparency is that anyone should be able to replicate your results. Researchers must publicly share these things. What assumptions were made, how he or she made the study, with what assumptions, how concepts are defined, what procedures were used, and any other information that's relevant for accurate replication. So these things must be there in any scientific publication, and an experiment should be scientifically published. And these are the areas that we always look for in our publications. Any examples can fit in here. For that matter, say for example, in a COVID-19 case, what assumptions were made between this for this experiment, what concepts were defined, what procedures were used to come to the conclusion, And if there is any other information, any other caveat, any other special condition that the experiment or the procedure or the process should be followed during the experiment, that must be there. In social science, it's fair. There are few generalized theories, very few generalized theories these days. Any other information is very important. Under which condition you studied that society or that community or that group, that's important. What assumptions you make, how concepts, how you are actually defining your concepts, what procedures were used. So this is what transparency is. Any scientific method must be transparent. Fifth principle is falsifiability. I mean, a falsifiable hypothesis is that which can imagine the presence of contradictory hypotheses. I have given a particular hypothesis. I must be aware that there may be a contradicting hypothesis, or maybe a host of contradicting hypotheses that are there. Without this falsifiability character, no study can be scientific. Well, the hypothesis that I am putting forward now can be disproven at any point of time if the contradicting hypothesis proves to be true. So first thing is that my hypothesis can be falsified at any point of time. That's the scientific method. That's a fifth principle of scientific method. The things get stuck when we talk about religious belief. Religious beliefs are not falsifiable. Here you are, the two religious beliefs. On the left side, the Babri mosque or the disputed structure, and on the right side, the Ram temple. So one group believes that, well, Babur has read namaz here. There is no falsifiability in this belief. And other group believes that, well, there was a Ram temple there. Well, that's also not always falsifiable. Then logical consistency. There shouldn't be any internal contradiction within your hypothesis. Conclusions based on observation should be logically consistent. Otherwise, you cannot really go or cannot really forward your hypothesis very long. And researchers should be consistent in what they count as confirmatory or contradictory evidences. So internal contradiction, should not be any internal contradiction as far as a scientific hypothesis is concerned. We should be very sure about what we are talking, what we are proposing, or what we are concluding. We shouldn't have kind of internal contradiction of what we are talking or what we are concluding. And another very important issue in logical consistency is that the observation must be logically consistent. The logical consistency of observation, I have talked about this logical consistency of the observation earlier, but well, it shouldn't contradict other observations at the same time within your hypothesis. And a researcher must be consistent in what they count as confirmatory and contradictory evidences. There may be, first thing is that when we talk about confirmatory evidences, it must be logically consistent, which shouldn't contradict your observation, or it shouldn't be easily falsifiable at the very outset. It shouldn't have inconsistency in the logic, and at the same time you must be aware of the contradictory evidences that may come and how you will fight that contradictory evidences with your logically consistent logic or evidences or observations. You must be very aware of that. So here we are, logical consistency. Maybe let's say this is another of my students whose name is Obiman. Okay, he is arguing with his father. He always needs extra pocket money. His observation or his conclusion is that, well, the father doesn't want to give me more money, so father doesn't love me. And his father thinks that Obiman is actually misspending the hard-earned money that he is giving to him. So there are two observations, two conclusions, two hypotheses here, and the two conclusions. Whether any of these two hypotheses or any of these two evidences are logically consistent, I say no, because Obiman's father doesn't have anything else in his life other than his two sons, and of course Obiman loves his father. He doesn't know possibly whether he loves his father. So this is the lack of logical consistency that we sometimes suffer when we formulate our hypothesis in social sciences. Now, to summarize, scientific method requires that we formulate hypotheses that are, number one, empirically testable, meaning the hypothesis must be supported or contradicted by observations. Replicable, meaning the hypothesis can be tested repeatedly. Objective, meaning hypothesis can be tested independently by others. Transparent, meaning the hypothesis and results are publicly shared, so they can be tested by anyone. Falsifiable, meaning that finding contradictory evidence is a possibility. And logically consistent, meaning that hypothesis is internally consistent and the conclusion to support or reject the hypothesis based on observation is logically sound. These are the 6 principles in which scientific method is based on. And one important thing before I leave this section, scientific method is only effective when it is used in the right attitude. In order to come up with better hypothesis, researchers need to be critical of their own studies and those of others. So a researcher must be critical of his own study and those of others. Otherwise, a better hypothesis won't arise. And they have to be open and transparent. They have to accept the critic and let go their pet hypothesis if others provide better explanations. That's the most hardest thing that the social scientists suffer from. Whatever they say, they think that's the final thing. That's the final observation, that's the final conclusion. they are not open and transparent. They can't accept critique in many cases, and they are very fond of their pet hypothesis until till they end their life, or rather till the end of their life. Okay, and then and only then the fittest and most plausible hypothesis survive. Now, next we go to the scientific claims section. The most basic science says that most basic claim is observation, on the basis of which we actually conclude in a scientific method. Well, not casual observation I am talking about. It's a scientific observation. An observation can be an accurate and inaccurate representation of the world. As I said earlier, we are very poor at observing, but well, we selectively observe. So the observation can be an accurate and inaccurate representation of the world. It can accurately represent the world if the selection is good, and it can be inaccurate representation of the world if we actually don't observe it properly or selection is bad. An observation on its own is not very informative. It doesn't describe the general relation between the properties. It doesn't explain anything. So say for example, I saw something. Say for example, I saw a cat running. Well, it doesn't mean anything. It's not informative. It doesn't give any general relation between properties, whether the cat always runs or whether the cat runs when it is hungry. It doesn't explain anything. But observations are very important. Unless we observe, we can't be sure, or we don't get any knowledge as such from the nature. These are the building blocks of empirical sciences. Observation is the building blocks. Observations are building blocks, but not useful of its own. It must be related with some theories or with some causal relationship must be there in observation. Say for example, here you may consider that all professors are fat. Well, you have the thinner professor here, same person who become thin and nutty professor's film. So it's not always useful of its own. I mean, if you observe this thing, say for example, you observe 100 professors there, and all of them are fat. Well, I mean, what, does it make any sense? You can say that, well, professors are always fat, but it doesn't make any causal relation. General relation between properties, it doesn't explain anything. If we want to explain why the professors are fat, that's a separate thing. No, why most professors are fat, okay? Observation become useful when they are used to confirm or contradict a hypothesis. Here, if we say that professors are mostly fat, if it is a hypothesis, then observations must be streamlined in that direction, and it must have some causal relation, and it must be related with a hypothesis. We come to the hypothesis now. Hypothesis is a statement that describes a pattern or general relation between properties. Hypothesis is basically a statement that describes a pattern or general relation between the properties. You have so many properties in surrounding you. Fat professor, thinner laborers, mediocre students. All those things are properties. You must find hypotheses to relate a pattern or general relations in the properties. If we relate work with obesity, then we actually say that, well, the professors don't have to don't have much physical labor, and the laborers have so many things to toil on. So the professors are fat and the laborers are thin. They don't have fat. Hypothesis can also explain the pattern that the plausibility of a hypothesis can range from very uncertain to very certain. Here you are. I mean, if the physical labor is associated with obesity and as well as the nutrition, then we can have a plausible explanation of the fatness of the professor as well as the thinness of the laborers. Now, plausibility of hypothesis, first it was very uncertain whether we say all the professors are fat, and professors are fat due to some other issues. It's very uncertain. Now that you have associated it with the physical labor as well as the nutrition, then you can actually become a certain hypothesis. It's a hypothesis that is certain. It can again be contradicted in future, but the hypothesis for now can stand. Hypothesis can be unsupported and therefore uncertain. For example, if it is new and still untested, I said it, fat professor and thin laborers, uncertain, unsupported and uncertain. It must be supported with scientific observations, and it must be tested over and over again. Hypothesis can also be strongly supported by many empirical studies and therefore more certain. So there you are. Hypothesis, which is a pattern, which describes a pattern or general relations between properties, can be very certain or very uncertain. It can still be new, unsupported and uncertain because it is new and still untested. It can be certain, more certain, because it is supported by many empirical studies and therefore more certain. Observation becomes useful when they are used to confirm or contradict a hypothesis. So, if the observation on fat professors, and the reason being that they are very greedy, can be confirmed or contradict a hypothesis, then well, observation is more useful. Well, it's not always true, but it can be. It can. You can actually lay the foundation stone of a hypothesis when your observations can confirm or contradict a hypothesis. Okay. Now, first we have seen what hypothesis is and how hypothesis works. Now here we are, the law. It's a special type of hypothesis. Law is a very precise description of relations or patterns. So precise that they are usually expressed as mathematical equations. There are so many mathematical equations in so many theories in social sciences. You go to any theory, particularly in economics, you get so many things, and of course in sociology and anthropology we have so many laws where we have mathematical equations. It is expressed as mathematical equations. They are also generally very well substantiated. They have withstood the onslaught of counterclaims, onslaught of contradictory evidences many times. So they are well substantiated, and that's how they got so precise. So law is a special kind of hypothesis which is precise. Well, this is another example that, well, you'll fall from up to down and you will get injured. Well, but the cartoon characters don't always get injured, or they survive in mysterious circumstances. But law is there, that the things fall from up to down. That's so precise. Now we have scientific claims. We're continuing with scientific claims. In the social sciences, laws are ever hardly formulated. I mean, we don't always formulate laws. We understand too little of people and groups yet to be able to specify patterns in their behavior with such a degree of precision that we can postulate scientific laws. These days we don't really postulate scientific laws. There was a time in social sciences, particularly during in the intervening period of the First World War and Second World War, where a particular trend in social science, that is Vienna Circle, tried to formulate some scientific laws. But well, they faltered more than they were right in various occasions. We are now, I mean, social scientists are now quite sure that we know or we understand very little of people and groups, and it's not prudent to give a term law to a particular set of hypothesis or conclusion. Now we come to the theory part. What is theory? In day-to-day life, theory means an unsubstantiated statement, an educated case. We always make this educated case. Well, you know, don't go in the dark. Don't do these things, and well, do these things instead. We actually give so many things in day-to-day life, unsubstantiated statement, that's an educated case. In science, theory refers to a broad, overarching explanation of many related phenomena. Science, in hardcore science, theory actually refers to broad, overarching explanation of many related phenomena. Say, for example, as I said, that well, uh, if we just release one thing on top, it will come in bottom. So the theory says, or law says, I mean, first it was theory, then it was law. This is a kind of overarching of the explanations of many related phenomena that we find in science. They relate and they formulate the theory. In natural science and behavioral sciences, a theory is built up out of hypotheses that are very strongly supported by empirical evidences. So, in natural and behavioral sciences, it is imperative, it is compulsory that your theory must have theory actually building up out of hypothesis which should be strongly supported by empirical evidence. Otherwise, the theory is doomed. Now, here you are. Social sciences. In social sciences, the dominant approaches are actually qualitative and historical comparative. So here, the theory is considered highly plausible when it has withstood attempts to refute it based on logical grounds as well as historical or qualitative analysis. So when we forward a theory, or when we actually accept a theory, it must have withstood attempts to refute it, serious attempts to refute it. And it must be based on logical grounds as well as historical or qualitative analysis. So, theory here runs like this. Face-to-face lies are spontaneous, while online lies require planning. So, if it is a theory, then it must withstand various attempts to refute it, and it must be based on logical grounds as well as historical and qualitative analysis. Historically, whether it is true that face-to-face lies are spontaneous and online lies require planning. So this theory, if it can withstand various attempts to refute it, it becomes a theory. This hypothesis becomes a theory. But if it can't, and if it must withstand the historical as well as qualitative analysis also. But if it can't, it's a casual observation. Now, in science, theories are most well-established explanations. Closest thing to certainty that we have, because they consist of hypotheses that have survived the scrutiny of the scientific method, and it is kind of certain things. This is a kind of well-established explanations that we see in science. Scientific theories are not always certain or true, and many well-established, well-substantiated theories that were ultimately replaced. So, I mean, once the theories are formulated in science, it seemed to be closest to certainty. until a contradictory theory proves it wrong. But when it is forwarded, it has withstood various scrutinies, and these scrutinies actually made this theory a well-established theory or explanations. Here you are. The theory is quite certain. I mean, as good as certain, and well-established theories may actually uh, replace it. In fact, Newtonian physics have been replaced by Einstein's physics. So, but when it was invented, it was a certain thing. It was very certain. Now here you are. The difference between social science and natural science. Now, lastly but not to the least, I must give you a message that West Bengal has been affected severely, first by COVID-19 and then by Amphan storm. Crores of people who have been hit by catastrophic Amphan are yet to get the basic necessities of life in different places of South Bengal. Kolkata Study Circle, which is organizing this lecture series, fervently appeals you all the participants to donate a token amount of ₹100 to our designated accounts, which will be used mainly for the relief purpose. The account details will be provided to you through your designated email account. In fact, I have started this lecture series on this. My inspiration was to give some relief to the Amphan storm. Otherwise, I don't have any compulsion to give this lecture series. And well, next lecture will be on 17/6/2020 at 7 p.m. Topic will be origin of scientific method, science and philosophy. Thank you. I guess you have some questions in the comment box. Just a second. Let me stop sharing. Yes, there are. Oh dear, 42 comments. Actually, so many comments, I can't. Thank you, sir. Thank you so much. Well, good. Let me go to the. Oh dear. Is it? Well, I guess there is no question that I've scrolled. Some comments are there. Well, I'm unmuting the participants just in case they have any questions. Can the co-hosts unmute the participants?
So the participants can unmute themselves. So if you have any questions, you can unmute yourselves and ask your questions.
So some questions are in chat box.
Some questions are in chat box.
Yes, sir.
Okay. You mentioned that the results must be same when replicated, but is it very in case of social sciences? As
বন্ধ কর ওটা,
there are
ওটা লেকচার হচ্ছে,
places,
আসতে দে।
different places. Well, that's Kullan that you have asked that objectivity for scientific study, social science. In social science, it is.
Yes, sir.
Well, that's a very debatable question. But scientific method demands that you will get the same result if you repeat the same experiments or if you repeat the same procedures. Well, if you don't get, then you will come up with another hypothesis. It's always an open field. The rag is always there. You can pull the rag of that hypothesis and build your own until a contradictory hypothesis gets in the center stage. Well, could you please elaborate different types of hypotheses? Which types of hypothesis is most accepted and authentic? Well, first thing is that hypothesis is for testing. I mean, the types of hypothesis which is accepted, once it is accepted, then it becomes a theory. And hypothesis can be contradicted. Hypothesis can be falsifiable. Okay, hard science bijoy bitan. Hard science to consider hard and generalized laws for any situation. But what about social science? These generalization don't seem too suppressive in social science. Yes, there is a. I mean, we'll talk about that in later lectures. But well, subsequent lectures we'll talk about it. Of course, I mean, whether we can actually generalize social situations, it's a very big question, and that's the main debatable point between the qualitative researchers and the quantitative researchers. We'll talk about that later. But right now, I am talking about how the scientific method had actually come up in social sciences. Just follow the historical or the analytical part. Okay. How we will explain participant observation through your scientific study, as it depends much on subjective viewpoint and our interpretation. Well, once again, I am talking about scientific method here. Scientific method, of course, does. I mean, it sometimes it creates bias, and well, generalization is sometimes very difficult. But well, you know what? Malinowski tried to generalize many things. Even he was a participant observer. So that's the beauty of social science. You can actually hold both trends, qualitative and quantitative, within your ambit. At one point of time, you can generalize, and at other points of time, you can't generalize. Are scientific methods always needed systematic observation? Of course. Scientific method, if it is scientific, then it needs systematic observation. Without systematic observation, you can't really withstand the contradictory evidences. How to develop a robust methodology for collecting samples in the field as sources of knowledge can be tricky. Yes, sources of knowledge can be very tricky. That's a topic, how to build a robust methodology for collecting samples in the field. What kind of samples you talked about, I really don't know. Whether it's biological sample or the sample study that you are talking about. But well, developing a robust methodology needs a kind of combination of both intense observation and systematic observation. Otherwise, you can't really develop a robust methodology. But it's a topic of a separate entire lecture, how to develop a robust methodology for our field studies. Is every hypothesis biased to its context till it's become a theory? Well, I mean, hypothesis per se is a kind of theory in waiting. If the hypothesis proved to be biased or proved to be unscientific, so to speak, we can't really bring this hypothesis to the theory level. That's important. But it's a kind of theory in waiting. If it becomes a theory, it means that it withstood many challenges. Okay? I think I have answered the questions that are there in the comment box. Just in case if you find anything.
So there's one question, sir.
Yeah.
From Shomojit Singaroy. Is hypothesis dynamic in nature as long as it's not becoming a theory?
Well, hypothesis and theory all are dynamic in nature. Hypothesis is more dynamic. I mean, as I said, that hypothesis is a theory in waiting. It always in flux. I mean, say for example, I considered something as hypothetic. And I found that, well, I tried to get evidences in favor of my hypothesis. Well, I find that, well, these evidences are not good to prove my hypothesis right. So I discard my hypothesis. I say, for example, I proved my hypothesis with the evidences that I got, and contradictory evidences, and a host of contradictory evidences and contradictory hypotheses came. my hypothesis is gone. If it doesn't withstand that kind of onslaught. So there you are. I mean, hypothesis is very dynamic, and theory, of course, in science also, theory is though less dynamic, but the theory is not immutable. It changes over time. As I said, the Newtonian physics, then Einstein's physics, then we have this nanophysics, and then we have quantum physics. So these are the things that are there in physics also. And as I said, it will be discussed in the subsequent lectures also. That philosophy has basically started from physics. Well, is there any other questions?
Yes, sir. There are 2 more questions.
Okay. But I can get is subjectivity possible in social theory? Yes, Shumon. Subjectivity is possible in social theory. Since I am now dealing with scientific method, I would say that it's not desirable. Well, in some other places, when we are talking about a kind of subjective methods, where bias is not bad, then well, of course, subjectivity is possible. And of course, in one condition, subjectivity is possible in social theory, because if the contradictory theory comes, it may prove to be subjective. Even most scientific theory can prove to be subjective. Say, for example, I will talk about this later. Positivism, logical positivism. It was too much scientific, but it was subjective in other senses. Scientific method is described by 6 principles. One is subject, or why it is not objective. I said it. Scientific method doesn't certainly doesn't really bang on the subjectivity. Subjectivity is to be discarded. That is what scientific method says. In social science also, the scientific method discards subjectivity. At least avoids it. As mathematical derivations are less in social sciences, does that mean knowledge of social sciences are more dependent on hypotheses and observations or theories? I mean, yes, social sciences is more dependent on hypotheses, observations, and theories. That's true. I mean, we also do many mathematical analysis, but well, this doesn't mean that we are based on mathematics. Social sciences are based on mathematics. I'll talk about it, mathematical knowledge and other knowledges, in the subsequent lecture. But mathematical, the knowledge of social science is more based on scientific, the hypotheses, observations, and theories. Even if we apply scientific method, the results may be different. Results may vary, not always be the accurate explanations of the phenomenon, since social sciences includes not only biases, but also informants. Well, that's an observation. Thank you for your wisdom. But since you may be missing the point, I am dealing with scientific method here. Social science always tried to be, for the most part of the history, always tried to be scientific. And I am actually trying to explain the rise of scientific method in social sciences. So, of course, we face these things that there are different informants are saying different informants are explaining this thing, one thing differently. Well, that's the problem that we have to deal with. I mean, we'll have to see, we'll have to repeat it. There is another way of verifying or validate your data, that is triangulation in social science, in qualitative research. I may take up this validation point also later, not in this series, in a different series. But it's an observation, and thank you for your observation. Sir, if we become unbiased, then can we become fail to understand about any particular community? Well, yes, I mean, there are pitfalls of science also. I mean, there are some shortcomings of science also. So these are the shortcomings. I mean, we just, when we actually see things in social, in a society, we tend to come up with some hypothesis, and we tend to test the hypothesis, and then we, if the hypothesis is good, then we forward this hypothesis. And deep inside, we try to be unbiased. But well, there are some bias is not bad always, particularly in anthropological studies. Nowadays, economists and other social sciences are following interdisciplinary, multidisciplinary methods, sharing qualitative and quantitative methods. It is challenging how we will incorporate the modern trend of inter and multidisciplinary approaches. Well, of course, my lecture is multidisciplinary in nature. First thing is that. Thank you for asking this question. If first thing is that there is a meeting point of qualitative and quantitative methods, which is a mixed method. Very few, in this lecture series, there is a less opportunity of discussing this thing. We'll discuss this very briefly. But well, we can always incorporate modern trend of inter and multidisciplinary approaches. I mean, say for example, anthropology and sociology, the classic duel between anthropology and sociology. One says I am the stronger, I am stronger. Other says I am the father. I mean, sociology sometimes says I am the father of anthropology. It's partly true, of course, but at this, the one thing that always converge sociologists and anthropologists is ethnography. And of course, I mean, we do, the difference between anthropology and sociology lies in the duration of the study and the nature of the study. We converge. Anthropologists sometimes do the large-scale, short-term studies with anthropological backgrounds, and sociologists also do many ethnographic studies, which are long-term, short-scale studies. So this is where we are. And of course, we convert with economists, we convert with psychologists, archaeologists, everywhere. I mean, this methodology is for all. Okay. Is there any other question?
No, sir, I think not. Oh, so there another question, I think.
Sir, there is a chance of biasness in the field box. Sometimes respondents are hiding something in or lying with to the researcher. How should we handle this? This is a typical question that I faced for the last 25 years. First thing is that if you're an anthropologist, then you don't have to be a Sherlock Holmes. Bias in ethnography is not a kind of banned thing. You take the version of the respondent, then you triangulate. There are many ways of triangulation. I mean, primarily there are three ways of triangulation. One is researcher triangulation. Some other researcher asks the same informant the same question, whether the informant comes up with the same answer is a very big question. Second is a theory triangulation, different method triangulation, should I say. Theory triangulation is also there. Method triangulation, the informant said something, you acquired the knowledge through interview, but you change your method, you observe. So that is method triangulation, and there are other forms of triangulations also. So these triangulations will help you to come up with so-called unbiased study or less biased study. But bias is not that bad in ethnography particularly. But well, I am again telling you, right now I am talking about scientific method. Here the bias is not allowed. Okay? Sir, are the theoretical constructs, propositions, boundary conditions and assumptions logically consistent with each other? Well, theoretical construct, propositions, boundary construct, conditions and assumptions. Logically consistent, it can be logically consistent if your observations are logically consistent. If your, the ideal question will be whether these things relate with each other. Logically consistent can be, each item should be logically consistent to make the whole thing logically consistent. Well, Hindus of Himalaya by G.D. Berman described this as an impression of management. Well, I don't know what he's talking about. Is there any other question? Co-hosts, Abhiman?
No, sir, not
No, sir.
not anything as well.
We have not even heard the lecture.
Thank you everyone for attending this lecture series. I hope I could answer the questions. If you still have some questions, you can do that through email, the designated email. And one thing I must say that, well, the next the slides of the next lecture, as well as the link for the next lecture will be provided you by tomorrow evening. Thank you. Thank you, everybody.